the grade book yet. I just got done grading them all this morning. I'll get it in there in a little bit. But if you missed out on the Schoology quiz, I will open it back up. It'll be open. It's not open yet, but it'll be open until Thursday. 11:59 p.m. Okay, so if you missed it, make sure you, and I'll remind you each day as we progress. Okay, so question for you: who went and got the book? Is it you have it already? Raise your hand if you don't have it. Okay, cool. So if you don't have it, do you have $5 with you? If you have $5 with you and you have your ID that's on you and you have a mask on your face, you can go over to Bare Necessities and get it right now. I won't start class. I'll wait for you. So just ask for the business calc. It's a red cover. Looks like that. Has a light bulb on it. Cool. Now I won't start teaching until you get back. Yeah, you got it? Got it? Okay. Go. I want to double check something. If you don't have the book, you can just talk to somebody or take a picture with your phone and take a look at it. So some of these I'm gonna stay up here because I want to write them. I want to show you a couple of tools that are pretty valuable. And we're going to our best friend Desmos. So remember, Desmos works on your thing. So I'm at the very top of the page. Find the page. It says on the top right corner, it says Graphing and TI Calculator. It actually should say Graphing and Desmos. But so again, Desmos is a really powerful tool for us. When you start learning more and more of the features of it, you start realizing this is a good go-to. Okay? So let's, if we took a look at the very first problem, it says write the equation of the line through the points 2, 6 and negative 4, 3, which basically mean in Algebra 1 means you would have done x1, y1, x2, y2, found the slope, then use point slope, plugged it back in, and then distribute over the parentheses the slope, and then add the y1 value to the other side, so then you have it in y equals mx plus b. Let's do this. Nope, done. So I'm going to go to plus. I'm going to create a table. Okay, so on Desmos, if you hit the plus button, there's things that show up. You have expression, note, table, folder, image. So we're going to use a table. And you're going to be mad at me. You're going to be mad at me as soon as you see this feature. Okay, now I'm pretty sure you have all seen 2 points, find the equation. Agree? Everyone has seen that. And you're like, it's not my favorite. So I'm going to plug in 2, 6. And let me make this a little bit bolder. So 2, 6, it gave me this green point. Okay, seem okay so far? So then I'm going to move down and I'm going to do negative 4, 3. Okay? So it gives us these 2 points, which are like, great, it gave me 2 points. I still have to find the equation. Yeah, we can kind of guesstimate that the y-intercept is somewhere above 5, has a slope of 1, 2, 3 over 1, 2, 3, 4, 5, 6, 7, 3 sevenths. That's great. But if you understand, well, most of you understand how your phones work because you see a lot of stuff that you use on your phone in different apps. So if I wanted Desmos to find me the equation of this line, this is how Desmos is going to work. So we're going to go y1, you just hit y and it gives you a sub right away, equals, or not equals, you're going to do the shift of the tilde key, okay? So if you're on a keyboard, the tilde is shift above the tab. If you're on your phone, you have to find that little tilde, the little swirly, okay? And then we can go mx1 plus b. And if you do this little equation under the next thing, so you have your table. This would work if you had a whole table of values. This would work if you had this. So this is my equation. It tells us, the stats. Hey, we have an R value of 1, and R squared value of 1 as well. An R value of 1 is excellent. That means it's 100%. That this is the only line that goes through those points. We have a slope of 1/2 and a y-intercept of 5. So if I wanted to find the equation of my line, it would be y equals 1/2 x plus 5, or y equals 0.5x plus 5. But that's our line of best fit. So Desmos, again, it's such a powerful tool for you, and I want you to be familiar with it. I want you to feel comfortable with it. The hardest thing on doing this is realizing a lot of students will want to just go y equals mx plus b, and you have to look at what it's titling your x and y values. It's titling our x value x sub 1. It's titling our y value y sub 1. So if you realize the tilde is the command that Desmos uses, because tilde is not necessarily used in math. So they've used that as their default to say, hey, what equation is going to work? So that little tilde is going to go for that. And that's a pretty cool tool, okay, because it gives you the information. Now, I apologize, it doesn't give you it as the whole equation written out. You have to realize that, y equals mx plus b is typically looks like this. So you have to plug your m and your b into your m and b to keep the y and the x alone, okay? So that's pretty fantastic. But I want to go to number 3. Can I go to number 3? You feel comfortable with that? So on number 3, we're just going to graph it. We're going to go 3x, and use the division, and we have x minus 2. Okay? So when you take a look at this equation, and it doesn't matter, this is called a rational function, if we want to stay mathematical. But basically, you have both a vertical and a horizontal asymptote to this object. An asymptote is something that our line approaches but doesn't cross. Now, there are times when you're doing these types of things, especially when it becomes a higher degree function over a higher degree function, you can find from time to time it will cross the x-intercept. So it sometimes the higher degree rational function, the rule of the horizontal asymptote almost seems like a suggestion, though it does exist. Okay? This particular graph, if we talk end behaviors, okay? So as I go this way in the x direction, it's going to continue to go. Now, take a look. Does this seem that this line here is coming down closer and closer and closer to a certain value? And if I were to go this way, does it seem like this line is kind of maybe coming up closer and closer? It's getting, so at the very far extreme right and the very far extreme left, the line or the graph itself is approaching some sort of value. Okay? It goes the same is with the range. So in the vertical direction. So as I go in this vertical direction, it seems that this black line is coming closer and closer and closer to a specific value. And as I go down, it seems that the line or graph is approaching a value as well. So this is kind of coming this way. This is kind of coming this way. So on the top, it's coming to the left. As I go up, as I come down, it's going towards this other value toward the right. And of course, if you zoom out on it, and it's just like anything, if you zoom out, you're going to start losing some of what the graph is saying. But I mean, take a look. Our graph, especially if you zoom out into the thousands, I can't even see my graph any longer. Okay? So let's talk about a couple of things that this graph has. So I'm going to go back to this, and I'm going to rewrite our equation. So this is number 3, and our graph can tell us everything that we want but we're just going to utilize this as a tool. So the first thing, we have all heard at some point in math that if the denominator becomes equal to 0, that becomes a big no-no. Agree? But we're going to change the term. We can approach something and get very close to something. It's called a limit, and we're going to get to talk about limits later in the semester. But right now, what value do you truly feel comfortable that if I plugged in for x, that it's going to give me a 0 in the denominator? What do you think? How much? 2. Yeah, if I plug 2 in top, I get 3 times 2, which is 6. And you're like, yay. But if I plug 2 in the bottom, I get 2 minus 2, which is 0. So I wind up getting 6 divided by 0. Okay? And 6 divided by 0, if I have 0 in the denominator, that means that we're creating something that can't exist. It becomes an undefined characteristic. So right now, we could probably feel comfortable saying a cheap terminology statement is this. Okay? So let's think about that x can't equal 2. Okay? So what we can use is, let's go back to Desmos and take a look at it. Let's write x equals 2. Okay? It becomes a vertical red line, or whatever line that it came to. So talk to me about that line. Is it horizontal or is it vertical? Vertical? Okay? If I were to track upward, and it looks like it's zoomed in too. As I track upward, does it appear that the black line is getting closer and closer and closer to it? I mean, it's not really an optical illusion, right? If I go back to the home screen, if I go down to the bottom as well, does it appear the black line is getting closer and closer and closer to the red? Does that make sense? It's never going to cross it. So what this means mathematically for us is that we have a vertical asymptote at x equals 2. Okay? We can't cross that, but as the whole theory of calculus develops a little bit, and we're getting into a little bit of calculus techniques, but I want to get into it in a way that we feel comfortable. No way, shape, or form does it mean that we go take the Calc AB exam, okay? But we're going to cover a slight part of it, but it just talks about, hey, we have a value that we're getting close to. Okay, so do we feel okay with a vertical asymptote? One, Desmos is available for you, so if you don't know all the rules to it, you can kind of look saying whatever makes the denominator 0. If you take a look at your graph and you start having like a vertical line, you could have 2 vertical lines that go upward, 2 vertical lines that go downward, one that goes one of each. Either way, it doesn't really matter. So vertical asymptotes we'll call VA, could look like any number of things. It could look like this. It could look like this. It could look like this. Or it could look like this. Okay? Those are all kind of what vertical asymptotes are going to look like. So just some ideas when you look at it. Those do exist. Now, let's talk about the exponents of this graph. 3x. What is x raised to if it's just x all alone? 1. Good. And then this x is also raised to the first. So I have 3x to the first, and then I have x to the first minus 2. Now, the minus 2 dictated what happened with the vertical asymptote. But right now, I have the exact same degree on top as on the bottom. Agree? Degree meaning the exponent. Degree is 1 on both. So if my degree on top and my degree on bottom become equal, some characteristics of this graph that we should know. There's a 1 in front of that. So this means I have a horizontal asymptote because the degree on top is equal to degree on bottom. This means that I'm going to take the lead coefficients. So I'm going to get y equals 3 over 1, which is just 3. Okay, so if I wanted to take that and go on to Desmos and say, okay, let's plug y equals 3 into that. Notice I have this blue line now. It's horizontal. Does it appear this black line is coming down to the blue line as I go to the right? As I go to the left, does it appear my black line is getting closer and closer and closer to the blue line? I hope you can see that. But those are just some definite things that Desmos can deal with us. Is there a solution to the problem? I don't know what he means. Does it cross the x-axis? Does this appear to cross here? So at 0, 0, we have a solution. All the solution is where does it cross the x-axis? That's all it means. Okay, now, that 0, 0 is an x and a y value. Agreed? So think about this. If I took my y0 and plugged it in, I'd get 0 equals. And if I plug my x0 in, I get 3 times 0, which is 0. 0 minus 2, which is negative 2. 0 divided by negative 2 is also 0. Okay? So there's just some things that the graph can tell you about. There's some things that you can look at to see where it would cross. Not every equation you plug in will have asymptotes. Okay? Some will have different. Can I move off that problem? Okay, I want to go down to number 5. So I'm going to clear these out. So I'm going to put in number 5. So I have y equals, when you're using the keyboard, you can come down here. Looks like I have a square root that I want to use, and I want to do x squared minus 16. Okay. Talk to me about what you see on that graph. Does it live below the x-axis? No. Okay. It doesn't live below the x-axis. It looks like it touches the x-axis at a couple of locations. And, Desmos is going to say, hey, what's special about these 2 points? What's special about negative 4, 0 and 4, 0? They're both solutions. They're both solutions. Excellent. That means I could plug that x and y value into the original equation, and you wind up getting 0 equals 0 both times. Okay? So if I take this negative 4 and plug it in, negative 4 as a quantity squared is 16. 16 minus 16 is 0. Square root of 0 is 0. 0 equals 0. This one works. If I take this 4 and plug it in, 4 squared is 16. 16 minus 16 is 0. Square root of 0 is 0. So those are my 2 solutions. But then it asks for something different here. It says we want to know what the domain of each of these would be. Okay? So let's take a look if the graph is doing anything beyond what it's doing. Now, for the most part, our graph is going to starts looking like it has these slight curves at the solutions, and then it kind of goes off forever to the right up and to the left up. Okay? So let's talk about what the domain of this would be. So on problem number 5, we had this domain. Put a question mark. We're just going to draw something like this. And negative 4 is 0. And I'm going to try and make them as close to symmetric as possible, but I did a horrible job. I failed art 3 times. So, sorry. So, think about the domain. Is this graph continuing to go to the left? And is this graph continuing to go to the right from what we saw on our Desmos? So let's talk about the domain. The domain, just as a reminder, these are the x values. Okay, we might have called this the input in algebra 1, and then you never saw it again since, you know, you had algebra 1. So where is this arrow pointing to? Where is it going in the x direction? Negative infinity. Okay. Where is this arrow pointing to? Positive infinity. Okay, so let's talk about the domain. So how I talk about the domain is I say this. We want to read the domain like we read a book or a text or something like that. You read it from left to right. Agreed? So read from left to right. Just like you read texts, books, magazines, articles, whatever. So my domain of this is going to go from negative infinity to negative 4, but we're going to put a hard bracket at the 4. The reason I put a hard bracket at the 4 is because I include that point. If that was an open circle, this would be a soft bracket or a parenthesis. Infinities always have soft brackets, but then it also goes from 4 to infinity. And that's what my domain would be of that particular function. Okay. Is there any questions about this so far? We feel okay? I know I hit some terms that you might not have used, but I don't think I made them impossible. Okay? So let's take a look at that. What time are we out of here? Because I will go on 10:06. Is that right? Yeah, 10:05. Cool. All right. I also want to take a look at number 6. So I was just going to do the odds, but we'll do number 6. I'm going to do it 2 different ways. So first way I'm going to do it is this. I'm just going to type it in as it sits on Desmos. Equals absolute value. Got to find the absolute value on here. Absolute value. There we go. Down there. X plus 2 is inside. Oops. Plus 2 is inside. Go outside of it. Minus 3. Okay, so we plugged it in, and we see this. Okay, it's not letting me highlight anything right now. Okay, so maybe let's type in y equals 0. And then maybe this will let us do it. Yep, it will. Okay, oh, come on. Stay there. Okay, negative 2.56 and 1.76. Now, how might we make this better? I might think about doing it this way. So let's keep this there. I'm going to get rid of that. And I'm going to take the left side, y equals 4 minus x squared. And then I'm going to take absolute value. Oops, let's do y equals, sorry. Oops. Y equals absolute value. X plus 2 minus 3. Okay. So solve using the intersecting function. We have a whole lot there. So I'm going to get rid of the 2 purple verticals in a second. But if we take a look at this purple, it goes right through this red and green right here. This purple goes right through the red and green here. Agreed? And we can zoom in on that a smidge. Do you feel comfortable that right here and right here? Come on. Go there, stirrup. Do you feel comfortable with those? So of course those gives us 2 points. So we have negative 2.541. That's only an x value. And I have 1.791. Okay, so I can kind of get rid of this, and it still comes out the same. So you're looking at the intersection of the red and the green. So if you set each equal to each other, all you're looking at on this is the x value. Okay? So what I'd like to give you for next time, and of course I want you to use Desmos, is I want you to finish, and I will check this off tomorrow, finish the graphing and TI calculator. I would like you to not necessarily worry about the TI, Desmos. I would like you to use the Desmos, but just do the best you can. We'll answer questions on it. I did quite a few of those problems already. Just finish the rest of that page. So I think it's number 2, number 4, and then the first number 6 are the only ones you have to do. Okay? Sound good? Now, of course, you're probably right on this, so you have the ones that we did in class done. We good? Everyone happy? Hey, and can I take a moment and talk to you seniors, all of you seniors? So I want something you have to know about me is I wear my emotions here on my sleeve. Okay, and a lot of people don't. I do. Okay, but I want you to know this. You are in the second semester of your senior year. Agreed? This is a exciting time, but it's also a scary time. It's a time that you might be a little saddened that, oh my gosh, I've been doing this. This is my 13th year being at kindergarten, being in some sort of institution of education. Now, you're going to see classmates and friends and other people who are in your class that they're going to be able to say, hey, I'm going to go to CU Boulder, I'm going to live in this hall, and I'm going to get a degree in this. And you're like, oh, that's cool. And then you're going to see somebody else that's like, hey, you know what? I'm going to go to Ohio State University, and I'm going to major in this. And you're like, oh, that's great. And they're like, what are you going to do? And you're like, I don't know. There's a lot of people that have the I don't know, and it's okay to have the I don't know. Okay, it doesn't mean you're broken. It doesn't mean that something's wrong with you in life. Okay, what it means is you are riding the path of life. There's a lot of people who think if I have to go to college right away, right out of high school, in order for me to become something. Okay, sure, but that's not reality. So this guy right here, I went to school part-time and I worked full-time. And I did that for a reason. I didn't want to have any debt. I had to pay for all my school. My senior year in high school, right around this time in my senior year in high school, my dad filed both corporate and personal bankruptcy. Everything that was saved for me to go to college, including what I put in, and what my grandparents put in, and what my parents put in, was wiped out. It was gone. Okay, this is reality. This was my reality. So I went to school part-time, and I worked full-time. I didn't have debt when I graduated. But it took me 7 years. And what saddens me is there's been, in my career of 26 years of teaching, I've come across more teachers who are like, gosh, you must have been dumb if it took you 7 years for your undergrad. Still paying your student loans back? Oh, yeah, I still owe like $38,000. Oh, I don't have debt. So I wasn't dumb. I made a choice, but I didn't, when I got to Arizona State, I said, oh, okay, mechanical engineer, that's what I want to be. And then I started seeing the stuff with prosthetics that they were designing, saying, maybe I want biomedical engineering. And I made it through my junior year, and I said, you know what, I really don't like engineers. I didn't like the people I was working with. I could handle it. Criminy, I was teaching calculus-based physics to 500 students that were my age or older. That was kind of cool. And that's what told me, hey, you need to go become a teacher. But even after 7 years, and I had neighbors up and down my street going, Chris, why is it taking you so long? Oh, I'm working full time. Why are you working? She keep telling you you're great. So things that I can tell you at age 51, that's my age right now. For the past 15 years, my house has been paid for. I own my house outright. Okay? There's not a lot of people who say they own their house. I own everything that I have. my wife and I have been able to save money to put our daughters through college so they didn't have to go through the same trials and errors as me. But is that helping them or is it hurting them? I know it sucked when I was 18, 19 years old going, and I got to work full time to try to pay for my school because there's no money available. And I didn't want to take student loans. I didn't want to do it. I kind of had a knowledge of understanding. But please know this, friends. Check in with one another often. Check in with those around you. If you haven't talked to somebody for a while, check in with them. See how they're doing. Okay? I'm not telling you don't become successful in life because you can. But just realize one person's path is not the right path for everybody. There's not one mold that is stamped. If you choose to go to college, great. If you choose not to go to college, great. If you choose to go into the military, great. If you choose to go into just working, great. Life exists with you for a reason. And because of all of you is what makes me the teacher I am. You guys give me a huge gift every year. 26 years of teaching. I've seen a lot of kids. And don't get me wrong, there was times that I'd be teaching classes, oh, you better do this to them after life. And I started thinking about it, but wait a minute, dude, I wasn't the person that I'm preaching to my kids. So just please know that. If you're concerned, if you ever want to talk, my office is right next door. Please come talk to me. Okay? You know, I'm here for you. I'm a big advocate for you because I know the gifts that you brought me, so let me give you gifts back. Gifts of, let's talk. What should you do? What's good for you? Okay? I'm off my soapbox now. And we're going to